Okay, everybody, this is chapter 2, section 4. We're gonna skip the identity here at the top of the notes. Identity is really just saying that if you have some number for a variable like x equals 2, that you could just go ahead and plug that 2 in wherever you see x. So we'll skip that for this section. We'll go to here. So you're going to have 5 steps. This is how to kind of remember how to solve equations. This is like an equation's really kind of got a lot of different things that you might have to do. And so we want to be able to have kind of a process here to do that. So you're going to write steps 1, 2, 3, 4, and 5, but I'm going to pull them all up and you guys could write them at your leisure. So if you want to pause it and you could write it down. So I would label them steps 1 through 5 and then go ahead and write what you would do for each step. I'll talk about it in a little bit, okay? So if you want to hit pause and you could write down this stuff and then hit play when you're all done. Okay, in step 1, you're going to deal with any parentheses. So that might be, you know, a lot of different things could happen, but typically you're probably going to have to distribute, or you might be able to divide. It kind of depends on what your equation's got. We've talked about that before. You might need to combine like terms. That are inside the parentheses. Okay, it doesn't mean like the whole thing, but just what's inside the parentheses. So lots of stuff could happen. Okay. Step 2, you're going to combine like terms on each side of the equation. So you want to put things together that are on the left side, that put things together on the right side. You want to get it down to where you only have really, in what we're doing, 2 terms on each side. So an example might be, you know, I get everything down to where it says 2 plus 1 equals -3 minus 4, something like that, where you only have 1 variable and 1 number maximum basically on each side. Okay. Step 3, you're going to gather all the variables on one side and all the constants on the other. Okay, so you're going to want to be able to do that. We want to do inverse operations. So if in the problem you're adding, to move stuff, you want to subtract. Okay. If it's subtraction on your operation, then you're going to want to add to move it. Okay. So that's the only way we can move constants and variables is by adding and subtracting it across the equal sign. Okay. Once we get the variable all by itself, and, you know, we've had this conversation too. Do I move everything to the left, or what do I do? What's the rule? There's no rule. You know, the book typically moves everything to the left first. And then I've said what I like to say. I like to move it to wherever the variable's the biggest because it'll always be positive. But you get to pick, okay? So typically, you're probably in most cases going to have to divide by the constant that's in front of the variable, okay? Sorry about my writing there. All right. If it's a fraction, then you'd have to multiply by the reciprocal. Okay, and we've done quite a bit of that. So you're going to have to make sure you do that, okay? And then obviously in math, you know, it's really nice when we do these problems that you can take whatever you get for x, wherever the variable is, and plug it back into the original equation and just see if it comes out to be equal on both sides, okay? So I'm going to do that today. We haven't really done that, but maybe for a couple of them. But for every problem that we're going to do today, I'm going to take the answer that we get and plug it back into the equation and see if it works. Okay, so these 5 steps, if you do them all, and it'll eliminate little mistakes, or you'll help find the little mistake. But if you do all these 5 steps, you're usually guaranteed that you're going to get the problem correct. Okay? All right, so we're going to go to the next page here, and we're just going to do a bunch of these. Okay? So I'm going to do one. I'll let you do one. I'll show you the examples by taking the values and plug it back in, prove that we got it right. Okay? So step 1, deal with any parentheses. Well, I don't got any parentheses. Okay? Step 2, gather or combine like terms. Well, I don't have any like terms to gather. I only got 2 terms here. I only have 2 terms there. There's nothing I can combine. Okay, so now I'm going to gather variables to the same side. So I'm going to take the 2x and move it over to the bigger variable 5x. But I have to do it by subtraction because it's the inverse. This is a positive 2. So I get 3x plus 2 equals 14. I'm then going to gather the constants to the other side, so I'm going to do the opposite. I'm going to subtract 2. They're going to go away. I get 3x equals 12. And then I want to solve for the variables. So in this case, I have to divide because that's multiplication. And I get x equals 4. Okay? So pretty easy problem. Some of the steps that we just wrote down, I didn't have to do because I didn't have those situations. So I kind of just keep going down until I can start doing stuff. All right. I'm going to take the x equals 4. I'm going to plug it in wherever I see an x and just prove to myself that I got it right. Okay. So wherever I saw x, I put in a 4. So 5 times 4 is 20 plus 2 equals 2 times 4 is 8 plus 14. So 20 plus 2 is 22, and 8 plus 4 is 22. So what I'm trying to get at the very end is just the same number on each side. That's my check. I checked my solution in the original equation. Okay. All right. So there you go. I'd like you to check it. I'll give you a story really fast here. When I was a freshman in high school taking Algebra 1, I had Mr. Wimberly. He was Algebra 1 teacher and a couple other math classes he taught, but he was also the varsity basketball coach, so he was kind of a tough guy. And, you know, we went that class every day for like 50 minutes, Monday through Friday, and we would just do problem after problem after he was done talking. And then he'd give us like 30 problems to do at home for homework. And every problem, you know, he'd give us something like what we just did. Every problem we had to show every stinking step, just like this. I'm pretty much doing what I did, you know, 1,000 years ago now. But then every problem we had to write that right next to it to prove that we were right. Now, that was a lot of work. And if he gave me 30 questions to do each night, I was really doing 60 because I had to rewrite it with a check mark next to it to prove that I got it right. Now, that's a lot of work, and there was a lot I'm not very happy with him sometimes, but I think it made me a way better math student than I ever could have been. Okay, because if I got something that was not correct right here, then I know I screwed up, and he checked our work pretty thoroughly. So I had, you know, then I have to go back here and find out where did I make a mistake, fix it, and then go back and check it again. So sometimes, you know, I didn't want to have to erase it and everything. So I really worked hard on getting it right. Okay. And then an explanation point to this little story I'm telling you. My dad was a really good mathematician. He was a chemical engineer, so he had to be really good at math. And basically, I was doing my math with him every night, and whenever I got a problem wrong, he would get a little upset with me. And there was a lot of him banging the kitchen table at night and me crying because he was yelling at me because I got a problem wrong, and you know, so that kind of stuff. So I got really good kind of out of fear, but it helped a little bit for me to keep checking my work to see if I got it right. Okay, so I'll shut up now. We'll let you guys go ahead and try this one. They have ask a question down at the bottom. We'll talk about it. Okay, so if you want to pause it and do this one, you can, but make sure you check it. Okay, all right, go. So I got k is equal to -4 as my answer. I went ahead and I checked it by plugging it back into the original equation, and I got the same thing on both sides. So that tells me I'm right. Down here below, the question says, could you have solved the above problem by subtracting 7k instead of 4k first? So basically it's saying, you know, back here, could I have subtracted this from the other side? And yeah, you can. And if you did everything right, you didn't make any mistakes, you would have got the same k equals -4 that way, and by plugging it back in, you would have gotten the same thing there. Okay, sure you can, but if you listen to me, to what I kind of do, I always move the smaller one over to the bigger one, so that when I do that, I'm always going to get a positive answer, and that helps me to feel a little bit more comfortable. I'm probably going to get this right because I don't have to deal with the negative sign. Okay. All right. I would have done, if we had subtracted 7k from 4k, I would have had a -3k, and then, you know, that just leads to mistakes sometimes. Okay. All right. Okay. So we're going to skip these two. We're going to go here. Okay. So now we're going to go back to those 5 steps. Okay. So remember, we're going to deal with parentheses. We're going to combine like terms, and then we're going to start gathering the variables and constants to opposite sides. Okay. So now we do have parentheses. Deal with it. Well, how am I going to deal with this? There's nothing here to combine, so the only thing I can do is distribute. I'm going to have to distribute here. Okay. Now let's reiterate this thing too. This is a mistake I see a lot of kids make, that we don't distribute all the way through. We only go here and we stop at that first term. You got to go all the way through it. Okay. Now I'm going to gather variables to one side and then numbers to the other. So I'll start with the variables first. It's typically the best thing to do. So I'm going to go ahead and I'm going to subtract 3x from both sides. That will get me a positive variable. So 7x minus 2 equals 33. I'm going to go ahead and do the opposite. I'm going to add 2 to both sides. So that's going to give me 7x equals 35. Then I'll go ahead and solve for my variable, and that's going to get me 5. So that's at step 4 of the 5 steps we had. The 5th step is to check it. So I go back to the original equation, the original one, and plug it back in. So I got x is 5. Okay, I'm going to do my math. So do what's inside the parentheses first. So 5 times 5 is 25, minus 1 is 24. 5 plus 1 is, or 5 plus 11, I'm sorry, is 16. So 2 times 24 is 48. And 3 times 16 is 48. So my check worked. Okay. Now, really, let's be honest here too. How long did it take me to write that check out? Okay, it did not take me very long to prove to myself I got it right. And when we're taking a test, I want to get every question right. Okay, I don't want to get some of them right. I want to get every one of them right. And the other thing too, I could probably check it by just doing it in my head, to be honest with you. If you do a bunch of these, you start getting really good at putting numbers together. You could do that in your head in like 5 seconds. Okay? All right, so I'm going to let you guys go ahead and try these two down here at the bottom. You're going to distribute first and then solve for the variable. And I want you to check these, okay? I'm not going to make you check every problem that we ever do. But right now, I want you to get confidence, hey, I did it right. Or I want you to be able to identify that maybe I did something wrong, and you can go back and fix it and get it right. Okay. So you can hit pause if you want, and you can do these, and then come back, hit play, and we'll go over the solutions. Okay. Okay, so there's your solutions, all right? Got a pretty nasty looking fraction here in the first one, but see, this is where, you know, going back and just having some confidence and, you know, and being proud of your work too. I might question if I did it right if I get a fraction like that, okay? I'm going to think that I did it right. I'm just going to go back and check really fast back here. Did I distribute it right? I get 8y plus 4, 2y minus. See, I screwed up. See, that's a 26, not 36. Big dummy. Okay, so that's why you check stuff. Don't just go, oh, I did all this work. I put in all this effort. Here's my answer. I'm done. That's just not a good way of doing stuff. Okay, so let's go back and fix it then. So this is what I had to do back in the day when, you know, Dad was yelling at me and Mr. Wimberly was making me do all this stuff. Okay, so let's, right off the bat, when I got that answer, I'm going, wait a minute, that's not right. Okay, I'm going to subtract 4. I get 6y equals negative 30. Divided by 6, I get y equals negative 5. Much more nicer answer, but still, I'm not sure if I did anything else wrong. And I'll be honest with you guys, okay, I did that on purpose. Okay, I want to make sure you understand that you need to really focus on your work, make sure everything's right. Okay, now what I'm going to do here really fast, okay, I'm going to check my work. Okay, the first equation was this. Okay, so I'm going to plug 5 in, or negative 5 in, wherever I see a y. Okay, so make sure I get negative 10 plus 1 in there. I get 2 and negative 18 there. Negative 10 plus 1 is negative 9, and 4 times negative 9 is negative 36. 2 times negative 18 is negative 36, so I got it right. I questioned myself when I got that answer. I go, wait, you know what? I can't get answers like that, but maybe I should go back and see if I made a mistake. And we found a mistake. You know, I was devious. I did it on purpose. Some of you might even say, no, you didn't, but you know, I'm trying to prove a point here. You can fix stuff and it'll be okay. All right, so the second question, checking it, I get this. I think that's what I have. Can't remember looking at. Okay, and I found out that A is 4. So I'm going to go ahead and put a 4 in wherever I see an A. Okay, inside the parentheses, 4 minus 4 is 0. And 0 times anything is 0. Inside here, I get 4 minus 4 is 0. Anything times 0 is, or anything times 0 is 0. So I got that one right too. Okay, checking your answers. Did not take me very long to check it. Okay, all right. So here, these are kind of these funky ones that these are proven identities. And you're going to see we're going to get some kind of weird answers. So I'll kind of explain this as we do it. Okay. So this first one, I can't do anything with this. So I'm going to come over here and distribute. Okay. And I'm going to get 10x plus 12. Okay. I need to gather the variables to the same side. Okay, but what happens is it cancels that out. I get 12 over here. It cancels this out. I get 12 over here. Okay. So another little story. Every math problem you ever do in your entire life is really just a true, false question. Does this equal that? Or like we were just doing, if I get something like that and I plug it back in, does it make it true? Okay. If I get something like this, that's a true statement. 12 does equal 12 all the time. Okay. So if that's the answer, then that means or that's what I got. My answer really is all real numbers, okay? So it's that funky looking R, or you could just write this. But that means I could plug anything in for X, and it's always going to be true, okay? All right, if you get something like this, I can gather some like terms over here. So I'm going to do that. So negative 3m and 12m is 9m plus 5. I'm going to gather the variables to the same size. So I'm going to subtract by 9m. They go away here, so that leaves me with negative 4. They go away here. That leaves me with just positive 5. Okay? So the variables have disappeared in both of these questions. First one, I got a true statement, 12 equals 12. But now I get something that's not true. Negative 4 doesn't equal 5. So what you're going to get for an answer is something we say no solution. Okay? Or you could put the 0 with the line through it. Okay? There's nothing I can put in for m in this case that will make that true. Okay? All right. So once you guys taken that information, go ahead and do these two problems. Why don't you go ahead and mute yourself and then do the problems and come on back. Okay, so little thing here in the first one, and I flipped these around. You'll notice I flipped the order. Okay, I have the same exact thing on both sides. So no matter if I subtracted the 12b or I added the 6, I'm still going to get the same thing on both sides. So if I'm getting the same thing on both sides, it's true. The answer is all real numbers. Okay, over here, I did a distribution. I flipped a little bit just to make it look halfway understandable. I subtracted 2x from both sides. I get down here. I don't have any variable left. All I got is numbers left, and they are not the same. So there is no solution to that one. Okay. Okay. So if these were just the basic 5 steps to solve an equation, you want to really stick with it. Check your answers. Most of the time you can do it in your head. So you might need to write some of these down if they're complicated, but really, if you're doing a test, you really want to work to get every one of them right. And if I could check every one to see if I'm right, it's not going to cost me a whole bunch of extra time. So give it a check, see if it's right. Okay? If you have any questions, get a hold of me. We can go over stuff. Otherwise, take care.